Okay, so I'm going to talk about pages 30 and 31 from your packet, but I also want to add in a little discussion on finding the range of a function over a certain interval for a domain. So say we take this same function, f of x equals 2x plus 1, and say I tell you to look for it over just a certain interval for a domain. So if we say f of x is 2x plus 1, what is the range over a domain of anything? We could say -1 to 3, for example. So what we would do would just look at, okay, what does a function do over that interval? And then we would use that to figure out the range over that interval. So what you could do is you could find the values at the endpoints, so f of -1 and f of 3. And the reason that this works is because this is a line. So a line is going to be either constantly going up or constantly going down. So the endpoints are all we need to figure out the biggest and the smallest values. If it's not a line, though, we would have to use more than just those two endpoints. So f of -1 would be 2 times -1 plus 1, which is -1, because -2 plus 1. And then 2 times 3 plus 1 would be 6 plus 1 equals 7. So the range would be between those two. So the range would be between -1 and 7. Again, because this is a line, I know there's not going to go any bigger or any smaller than what the endpoints have. But we can check it using our calculator as well. So 2x plus 1. I'm going to do a new graph here. This is my iPad Inspire, 2x plus 1. And then I'm going to go here, I'm going to look at the table. So I'm going to look between the x values. So we wanted an x value of -1 to 3. That was the domain we were looking at. So from -1, it's at -1, and then at 3, it's at 7. And as you can tell in the table, it's not going to go any smaller or any bigger than those two endpoints. So it's not going to be any smaller than -1 and not any bigger than 7. Again, because this is linear, it's not going to go up and then back down over that same interval. It's going to keep going up or keep going down. In this case, it's constantly going up. So -1 to 7 would be the range over the interval. If it was something different, say it was like f of x equaling 2x squared over an interval, we could do the same thing. So what is the range of this over some interval? We could say, I don't know, how about 1 to 5? So we could do the same thing. So go back to our calculator. We're going to plug in 2x squared as f of x. So I'm going to go back here. I'm going to do a new one. So 2x squared. And then again, look at our table. So it was from 1 to 5, the interval. So this y value to this y value. And again, you can tell it's only increasing over this interval. So it's getting bigger, 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 all the way up to an x of 5. So we don't have to worry about if it dips down or anything in between because we can see the smallest value, we can see the biggest value. So 2 to 50 would be the range. So the range would be between 2 and 50. And I'm using inequality notation here, but it could definitely be interval notation as well. This is inequality notation. This is inequality notation. But we could say 2 to 50 like this for the range. That would be interval notation. It means the same thing. Okay, so that's how you do. That's how you do a range given a specific domain between two numbers. You just basically look at the table or plug in the numbers and see the biggest and smallest ones to find the range. For this page, we're not going to do that same kind of thing. We're going to do the whole function, but looking at just parts of it for the table and then make a graph of the whole thing. So I'm going to look at, putting in all these numbers into the function. So 2x plus 1, so 2 times 1 plus 1 would be 2 plus 1, which is 3. And then 2 times 2 plus 1, so 2 plugged in for x would be 5. 2 times -3 plus 1 would be -5, because -6 plus 1, -5. And then 2 times 0 plus 1 would be 1. 2 times -2 plus 1 would be -3. So they're a little bit out of order. The inputs here, they're not from least to greatest, which is totally fine. They don't have to be in any kind of order. You can still make a function. So x of 1, y of 3. 2 is 5. -3 is -5. 0 is 1, and negative 2 is negative 3. And you'll see this all lines up because this is actually the graph of a line. I think I messed one of these up, didn't I? Yep. The negative 6 is wrong. It should be negative 5. There we go. They weren't quite lined up, so I could tell something was wrong. Use my ruler. There we go. Nice long line like that. And you can check it, of course, with the table and make sure that these points line up. So the domain and range of this function, it's not asking us to look at just the table here. It doesn't want just this domain and range. It wants the whole function. It just made we just made a table with some inputs and some outputs, but it wants the whole function. So domain and range would be using interval notation. So domain is all the x's, which could be anything. There's no x's that don't work here. So we're going to say from negative infinity to infinity, because everything works. And for the range, very similarly, we're going to have everything as well. There's nothing that we can't reach with a y value. It goes up forever, and it goes down forever to the left. So there's no y value down here we wouldn't reach. You just have to extend this down and find an x that would get to that y. So that would be the domain and range. You could also say for these, if it's easier, all real numbers. That's how we also say that. But it does say interval notation, so that would be how that looks. Remember, we never use square brackets on infinity or negative infinity because they're not actually numbers. We cannot actually get to those locations. So you can't be there, so we have an open parenthesis to say that. Okay, for the next one here, plugging in these numbers to get the outputs for this function. So 2 times x squared minus 9, so 2 times 1 minus 9 would be negative 7. Same thing for negative 1. Because squaring a negative 1 would be the same as squaring a positive 1. 2 times negative 3 squared would be 2 times 9. Minus 9 would then be 18 minus 9, which is 9. Similarly here, 2 times negative 2 squared would be 2 times 4, which is 8 minus 9, which is negative 1. Similarly here, and that one would just be negative 9. So we're going to get this symmetric looking relationship here, where we have similar y values, or same y values for different x's, which is totally fine. It still is a function because you can have repeated y's, not x's. So 1 and negative 1 are both at negative 7. Negative 2 and 2 are both at negative 1. Negative 3 and 3 are both at 9. And then 0 is down here at negative 9. Now, we don't want to use a ruler for this because this is not a linear relationship. This is our parabola, our quadratic relationship, so it makes a U shape. So just draw a curve in as best as you can on both sides here to connect these, but this is not going to be linear, so definitely don't use a ruler. That one's g of x, this one's f of x. Okay, and then domain and range. So domain and range of this one using interval notation. Domain, again, there's nothing we can't use for x's. You can square any number, decimal, negative, positive, doesn't make a difference. So all the inputs are fine. And for the range here, our smallest y value is right down here at negative 9. That's the minimum. So we're going to start with that. And then it never really reaches a maximum. It goes forever. But we can't include that, but we can include the negative 9. So that would be the range using interval notation. For the next page here, so a little bit trickier for this one. You might want to use a calculator to do these if you're a little bit stuck on square roots. So square root of 2x plus 6. You can certainly use a calculator to do each one individually or make the table and then just fill them in. Just make sure you fill them in correctly because, again, they're out of order, which is fine. I'm going to kind of talk through it, though, without a calculator just to see how that goes. So putting negative 1 in for x would be a square root of 2 times negative 1, which is negative 2, plus 6, which is square root of 4, which is 2, which I know is very fast. So let me show it on the calculator. So I'm going to do a new calculator page. So square root of 2 times negative 1 plus 6. You can do it all like this, and you can get your answer from there. So that would be 2, because it's square root of 4, which is 2. And then for the next one, I want to just make the x 2. So I can just go back up here, and I can copy and paste. So on your calculator, you can just hit the up arrow a couple times, and then hit enter on it, and it'll copy and paste. So 2 times 2, and then plus 6, if we just change the input there. So that would be about 3.16. Just to round it best we can here. 2 decimal places should be just fine. And then 5, same idea. I'm going to copy and paste here. You know what? Actually, I'm going to save some time. Let's go to a graph. So let's do a square root of 2x plus 6. Make sure the whole thing's under the square root, and then hit enter. And then we can go to our table again. Control T for you guys. For me, it's like this. And I can get my numbers that way. And if you highlight a single y value, you'll get more decimals. You'll see up top there. So that way you can get a more accurate answer if you need it. We don't need that many decimals, but in case we did. Okay, so what I'm going to do is I'm actually going to open this up and see if I can split this side by side. Will this work? Let's see. Nope, it will not. Okay, well that's fine. I'll just switch back and forth. So 5 would be at 4. 5 is at 4. Negative 4, let's see what that is. Back to negative 4. Ooh, error. I wonder what that means. Let's write it down. Error. Does negative 3 work? Yep, negative 3 is 0. 0 and 1 are our last ones. So 0 is 2.44 and 1 is 2.8. I'm going to call it 2.45 actually. And then 2.83. 2.45 and then it was 2.83. Okay. Okay, so when you make a graph out of these coordinates, we actually don't need to use all of them. We obviously can't use things that say error, because where's error on a graph? Doesn't really show up. So let's use the ones that are easy. So negative 1 is at 2. 5 is at 4. Negative 3 is at 0. And that's about it. Looking back at our graph, we can see the shape of this. And we can use that to connect these and make the shape like this. That's what the graph would look like, where it starts kind of here and then it goes forever to the right. So I put an arrow on it to show that it could keep going to the right, but not anymore to the left. So no arrow to the left. So for the domain, it looks like negative 3 is the smallest number that works. Everything below that doesn't seem to be working. You see errors showing up there. And if you're not quite sure, like would negative 3.2 work, negative 3.5 work, we could actually go to our table settings and you could make this count by something different. So if you go to the menu and then go to your table settings, you can make it count by like 0.5s here or whatever, or 0.1 even. And you could look closer at the individual numbers. And you'll see here it said non-real calculation. So there's an error happening. So anything after negative 3, now we can see a little bit more for sure, is not going to work. Even negative 3.1 is not going to work. So our domain must be from negative 3 to infinity. Or we can have negative 3, but we can't have infinity. Now, I just used the wrong notation. This is interval notation. It wants us to use inequality notation. So, way to go, Mr. Fisher. Let's fix it. So, negative 3 is less than or equal to x is less than infinity. That says the same thing as this, just uses inequality notation instead. And then for our range, the smallest y value is actually 0. So 0, 2, and it's kind of hard to tell the biggest y value it's going to be. It kind of looks like it's going to kind of taper off at some point, but believe it or not, it's actually not. This is actually going to increase forever. It's just very hard to tell. So how can you tell? I mean, I just know what the function is, but how can you tell if you're not that familiar with this kind of function? Well, go to your table here. If I go back, let's change the table. Let's start at, I don't know, 5, and let's count by a bigger number. Let's count by like 5s. And let's see how that looks. And you can kind of scroll through, and you can see, okay, is it ever going to taper off? Now we're at 20, 25, 30, etc., etc. It's never slowing down. It's increasing, not by much, but it's never reaching like a point where it levels off and doesn't get anything higher than that. It's always going to increase forever. And if you're really not convinced, change it again. Let's start with this really big number and count by a much bigger number. How about 100? That way that'll probably convince you. Now we can see it's still increasing forever. Hopefully that's pretty convincing to show that the range I should say, is never going to be, it's going to always go to infinity. It's going to increase forever. I'm going to get rid of this interval notation just so we don't think it's the right answer there. Okay, and the last one here. So this symbol is the absolute value symbol. Okay, so if you don't know what that means absolute value. So on your Inspire, you could just type in ABS parenthesis, and that brings up absolute value. Or you don't have to. There's a button you could use as well that gets to it. Let me see if I can find it. I think I have a calculator. I do have a calculator. Look at this. Cool. Okay, so this is the wrong color, but it's the same idea. So the absolute value button, it looks like a little LOL. So it shows up right here, okay, and it looks like LOL. If you push that button there, you'll get a little template that looks like this, and then you just type into that box to get the absolute value. So I'm going to show that on my app version, and then do the best you can with your calculator. I'm going to erase that now. Okay, so absolute value of x minus 3. Or you could just think, well, what does absolute value do? It makes it positive. So if I just plug these numbers in, it's really not that bad to do. So like 1 minus 3 would be negative 2. Absolute value would be 2. Negative 1 minus 3 would be negative 4. Absolute value would be 4. Again, just makes it positive at the end. So negative 3 minus 3 would be negative 6. Absolute value is 6. 3 plugged in would be 0. 3 minus 3 is 0. 7 minus 3 would be 4. 2 minus 3 would be negative 1, so 1. And then 0 minus 3 would be negative 3, so then 3. And if you don't believe me, let's go back to the calculator and let's show it that way. So let's do a new graph here. So absolute value is the one right to the left of the 7 here, this template. And then I'm going to type in x minus 3 inside, and then we'll get our table from there. And you'll see hopefully the same numbers that I got. Let's check our work here. So at 1 is at 2. That looks right. Negative 1, I got to scroll up here. Negative 1 should be at 4. Let's put these side by side. Let's see. And then negative 3 I don't have yet. Should be 6. 0. 3 should be 0. 7 should be 4, 2 should be 1, and 0 should be 3. Okay, those all look good. All right, so now we're going to make a graph, and we're going to use the picture we saw in our graph to help us. So it makes this V shape. So when we make our graph, it should also make a V shape. So 1, 2, it's not super accurate. Let's try again. So at 1, the y value is 2. At negative 1, the y value is 4. Negative 3, it's at 6. 3 is at 0. 7 is up at 4. 2 is at 1. And 0 is at 3. Okay, so we get this V shape. It goes like that and like that. And the graph does continue in both directions. So if you were to check that on your table, you will see that go forever in both ways there. That's k of x. So domain and range with inequality notation. So domain, there's no numbers that we can't type in here. So everything's going to work. So inequality notation, we're just going to say negative infinity to infinity. Because you can put any number into an absolute value of minus 3, and it's not going to be hard to do. It's not going to be a problem. Whereas with the square root, we couldn't do a square root with the negatives. That's why certain numbers, like negative 4, that made the inside of the square root a negative, which made it an imaginary number, not a real number, which was why we got an error there. Whereas for these, there's no errors because you can do an absolute value of any number. And then for the range, well, I see the smallest y is at 0, and the biggest y is infinity because it goes forever upwards. And again, if you don't believe me, let's go back to the table. Let's change these table settings. Let's make it count by something, I don't know how bigger, how about 25, just to make it count really fast here. And then we can scroll and you can see to this direction, it gets much bigger forever. The other direction also gets much bigger. The y values get much bigger forever as the x's get very negative. So my arrows hopefully make sense to you because both directions it's getting very big as you go that way and to the right, but it's never going to be decreasing. And that's it. Hopefully that was somewhat helpful to understand those two pages. I should be back next week on Tuesday, and we'll do more reviewing then.